Okay, let's go. Welcome to this session. We are going to talk about a way to elastify your application and move from SQL to NoSQL in less than 1 hour. This talk will be in English, but in French-English. Sorry. I'm David Pilato. I'm developer evangelist at Elasticsearch, and we as a company are developing Elasticsearch, the product, Logstash, and Kibana as well.
And I am Tugdual or Tug. I'm working as a developer advocate also, but in CouchBase. And CouchBase is developing an open source NoSQL database named CouchBase.
So the first question we should ask ourselves is why we should move.
So many reasons for that, but one of them is definitively the scalability of your application. More and more applications have more data, more users, so more access to the database. And it becomes a pain now when you have a very large database on a very large set of users to continue to grow your application. So instead of moving on a bigger server, then another bigger server, what we are trying to do by moving to NoSQL is to do the same thing of the stuff that you are doing on your application server, meaning you add more and more hardware, smaller hardware, but you add more and more. So if you need more power, you add new servers. If you need even more power on more users, you add even more servers. And one of the things we do more and more is to do that on the cloud using simple VMs. On more power you need, more VMs you add. And any other subjects that could be interesting when we talk about moving to
Sure.
NoSQL?
When it comes to search in a SQL world, you have to know in advance in which field you are going to search. Basically, you have to ask your DBA to index that field. Otherwise, it won't work. Also, searching for text, I mean full text search, could be a pain. Think about using like queries with wildcards. It doesn't scale. So the idea here is to use a search engine for searching. Crazy idea, right? So with a search engine, we basically build an index based on your document you send, and then we search into it. So these are the two main points: scalability and search features as well. To demonstrate that, we are going to start from a legacy application. And this application looks like this. So we have a SQL database. Then we use a Hibernate framework for persistence. And we use servlet and GSP. This is something you are probably used to find in your legacy systems. So we are going to start from that.
And one way of starting, instead of just changing the persistence, it's also interesting to be able to give access to this data to more developers, to more users. So do you have any way that will be interesting for people to kind of use our database, use our business logic as an API instead of using simple UI?
So the first step will be to restify our application and to provide web services that can be consumed from mobile application, for example.
Oh yeah, so it makes a lot of sense now. So we have access to the data from an external sources, so any application will be able to consume that. But since I am doing that, exposing API, this means more user, potentially more user, especially if we talk about mobile, and probably more data. So this is also why it's interesting to change the data store, use a NoSQL database as a data store, and we will see that a part of the benefits of NoSQL databases are the flexible schema, meaning I take my document and I save it as it is inside the database. But what can I do to query that?
No, first you have to build a UI.
Yeah, one important part, obviously, is to give the same service to the user, meaning I want to be able to expose this data in the same web application. But instead of accessing directly the database from my application, I will consume this API from my UI. So as I was asking, is what about
search.
query and
It's
search?
time. So let's add a search engine after CouchBase. So here we are going to use Elasticsearch because it's the best search engine ever. Okay, I work for Elasticsearch, so don't trust me, just try it. In a few minutes, it should be fine to have an idea about it. CouchBase team is providing a plugin for Elasticsearch, which helps a lot to push the CouchBase document into Elasticsearch, and we will show you how we synchronize our data from CouchBase to Elasticsearch. As both systems are document-oriented and speak JSon, it's really easy to edit. Elasticsearch is providing as well a REST API, so you can basically connect directly your UI to Elasticsearch and search directly with Elasticsearch.
And can I do more?
Yeah, with Elasticsearch, you can as well compute analytics, which is what we call facets. Everything is in near real time, 1 second delay, that means. So we can build now nice dashboards using a project which name is Kibana. And this is what we are going to show you. So I sum up things. We are going to follow those steps. We are going to show you the legacy code. Then we are going to add a REST JSON layer. Then we are going to move the SQL persistence to CouchBase. We are going to add the Angular JS UI. Then we will add Elasticsearch, and we will play a little with Kibana. Okay? Yes, thank you. So let's start the demo. You can find everything on GitHub. If you want to take a picture, it's now. If you want to replay that demo. Basically, we have some branches. We are going to switch from branches, and you can replay everything at home.
And one of the goals, it's not to build the best application in terms of architecture, but just to show you that it's really easy to take your existing application, your existing knowledge of your application, and move to a new architecture, starting with REST, new storage with JSON document in a NoSQL engine, and using advanced query capabilities using Elasticsearch.
So we are going to manage some documents in our project. That documents are persons. In persons, we have the name, we have a date of birth, we have a gender, we have some marketing data here, and we have an address. I'm sorry. Oops. Where is it? Okay. The address looks like this. I'm sorry. We have a country, a zip code, a city, and a country code.
So a basic set of class that you use as your model for your application and as your model for your database.
We are using Hibernate here. So, and we are using a Hibernate template to simplify things. So, for example, to get an element by ID, we simply use the template and we ask for a person with that ID. And when we want to save the person, we use the merge from Hibernate template. So that's easy. About search, let's have a look at the search.
So which kind of search query you can do?
So we would like to have a file like Google search. So this is what we built and what we have from the starting. We have a query, and we use here a like query. And we apply that query on the name field. Okay?
Okay.
So, yes, this is it. And I have now to show you.
Do you have a running app, or do you want to show more stuff?
Yeah, I'm going to show you that we are going to inject our DAO. And then when I have to get a person, I get the parameter. And then I use my get, just what I showed you before. And I set the person in my as an attribute in my request. And then I have to open a view. I won't show you the view. Doesn't make sense.
Basic servlet GSP application consuming Hibernate object that has been injected using Spring configuration, but just so standard Java application that you have been developing for many years, I guess.
So we are using Maven here to build the project, and oh, we have some tests. Cool, that's a good idea. We build a web application, and then we start the application itself. We inject by default some elements to play with. So now I can look at this. Wow.
So yes, so we have
Beautiful.
documents, or we have at least persons coming out of your database, but can we do some search?
Yes, we can search for Joe, because we have the like, that works.
Can I work for Joe Smith, or?
Oh yeah, Joe Smith, it should work. Yes.
And Smith Joe, if, for example, if I want to search for, I don't know, I'm not sure about first name, last name kind of stuff.
Smith Joe is the same person, so, oh, doesn't work. Of course, you remember that we have implemented it with a like, so it cannot work.
Okay, so...
Maybe we can search for...
I see that you have multiple columns. Can I search, for example, for city or country?
Germany, let's say Germany. Okay, you remember we have only applied a search on the name field, so we can search for country. If I want to do that, I have to implement something else and to add the country as a field in my search request. So basically, we want now to start from this point, and we are going to first restify our application. So I am going to change my project. I'm going to switch the branch.
So we see we have a database application using Hibernate, simple queries with a like on a specific field. And let's now expose the same data using the same service layer, meaning Hibernate for now, but expose that as a REST API and giving back on force JSON document.
I'm going to run the project again. So I'm starting, I've just added some Spring layer and JSon as well for this part, because we are going to use JSon to map our bin to JSON documents. So I have started my project again. What I want to show you here, I want to simply run a get on a person, and it doesn't work because it's not already implemented here. So I have a 404 error.
So let's create this service now.
Let's create the service. I think it's here. So, yes. So the first thing I have to do here is to implement the get. So I have a DAO. I can use it here. Person DAO.get. And I have to parse it with an ID. Okay, fine. So now I have a person, but it's not enough. I have to tell Spring to map everything. So basically, I have to add a request mapping.
So here it's really just using the REST annotation. So in this case, Spring, but could be JAX-RS or any framework based on JAX-RS. So just exposing from your Java application your business object and business services as a REST API, and we will serialize them into JSON, from Java to JSON, from JSON to Java.
Yes, so here I am extracting from the path the ID, and I'm listening to the get method, HTTP method. My method is return a person. I am going to use behind the scene JSon request body.
So
here,
just explaining here that we will return an object.
What's happened? Response body. Sorry.
As a
this is a response.
As a JSON object. Yeah.
Okay. Response body, and here I have to say this is a path variable. Yeah.
As you know, probably if you do REST already, we don't usually use query parameter anymore. When it makes sense, we use path parameter. So it will be something like, as you see at the top, my REST API /1, because it's my version of the API /person, then the ID of the document or the person as part of my URI.
So this is it for the get. I'm going to show you with a copy and paste because it took me too much time to do it live. Okay. The same thing for the put, for the create. So basically I'm using here JSon. I'm then read my JSON document I get from the REST API, and I map it to a person object, and then I use my DAO to save that person, and that's it.
We use a string as an input parameter just as another way of showing you that you can not only use person if you want in and out, but you can also use direct strings that will be JSON documents and do the parsing in your code using JSon.
So I clean my project, I build it again.
And we are still on a SQL database, so injecting some documents. Oh, person, sorry. I am biased, I'm using always the word documents now.
So now I can run again the get, and now it's implemented. So I have my JSON documents, I have my Joe Smith here, and some data, some random data, I assume. But we are still persisting our documents, I'm saying document myself, in our SQL database. Can we move to something else?
Yep.
Yeah, I'm sure we can.
Yeah, we can. So as I said, one of the benefits of building an API is to expose that to more user, more developer, but we may need more speed or more scalability. So doing the same checkout of a specific branch, just the begin, and I go back to my code. If I go to the person service, so I have all the code that has been implemented by David about working with a database. But now what I want to do is I want to switch to a NoSQL engine. So a NoSQL engine will be a database that you install somewhere on a driver that you use to connect to the cluster. In my case, in the case of CouchBase, we have a connection we can get as a singleton because it's thread safe and non-blocking, so you don't need pool of connection. It's managed by the driver itself.
Do you have clients for other language than Java?
Yes, we have most of the languages, .NET, JavaScript, C, PHP, even Go, if you want to. So the way I connect when I try to get a connection to my cluster, I just give one or multiple address in my cluster. In this case, we will start with one single node, and the driver will get the topology of the cluster. If you have 5 nodes, 10 nodes, it will be connected to all these nodes. And as you can guess, working with Maven allow you to get the driver directly from inside your dependencies, inside your project. So now that I have my driver as part of my application, how do I use it? Let's see with a get. So I have the get. In this case, what I will do is I have to call my database and get the document on a specific ID. And to give the flexibility of working with documents for this specific example, I will just work with strings get on back. So I will return the string, same ID, but here what I do is I will connect to the client. I will use the client, do a get, and what I need to use is I need to use the document ID, so the key of the document. The way we work, and this will depend on each NoSQL engine, but one of the best practices we use with CouchBase, we usually prefix the key with the type of the document, because you can store anything you want inside your database. So I have created a small util class that will say I want to use a person and I want to use it with this specific idea. If we look at the code, it's just a very, very simple concatenation of strings. Okay, prefix, so person, column, and the ID of the document. So this will return me an object, and this object, I will transform it as a string, and this is it. If I want to save something inside the database, I will do more or less the same. Instead of connecting to a specific mapper, to a specific database, and get DAO and do the mapping, what I can do is I will use another function from my database that will be client.set. And we have different functions like add or replace, depending on the operation you want to do. The set will be an upsert. We'll take the document and we'll save it inside the database. Same, I can use key util next value if I want, so I will use a sequence for equivalent of a sequence that is coming from the database. And I will, interestingly, I can do this just for as an information. You can use inside CouchBase a time to live. It will automatically remove the data from your database after a specific time. For example, in this case, when I say 0, it will stay in the database until I do a delete. If I say that, after 10 seconds, it will be deleted automatically. We use the same protocol on the same API as Memcache. So now that my web service API is done, I should be able to test it, at least to be able to get on back document inside the database. So let's start. Let's stop the server. Since I changed my class, I run the server with my new code. And I will see if
CouchBase, connection to CouchBase.
Yeah,
that's cool.
Let me just do something because.
So you have to inject.
Yeah, I have to check if the injector is implemented. I don't remember in this.
Okay, this is an utility method to inject some documents.
I will go in my database. So we have an administration console.
With R.
Yeah. And I have some document now in my database. And as I said, we use a key here, person dash column 1. And if I want to consume my service now, I should be able to do that and see if it's working. Yes, it's working. It's getting the document directly out of the database without changing anything, without transformation from now.
But can we inject more documents? I mean 10,000 documents, for example?
Yes, but instead of 10,000, I will just do 500,000 just to give you some activity on the server. So same command, but instead we inject 500,000 of document. You will see some stats about what's going on inside my database, how many documents are injected. Remember that we are currently working on one single node, but if you are working on a cluster, that is most of the time what you do, you will distribute the write and distribute the data on all these nodes.
Cool. So now we are injecting some documents. Can we build our user interface?
Yeah, so now that we have a REST API, and in fact the full REST API will contain many other things like the search, and I will just check out this code just to show you. So I just implemented the create, and I just implemented the get. So let Git check out
the final version.
Yeah, the final version, and here it's using the same code as before, but it will use CouchBase everywhere, including doing some basic query. I don't remember where it is. Doing the search.
It's here.
Doing a search using some specific view, so using indexes inside the database. So let's start this, just to get to be sure that we have still the system running.
I don't know how many documents we have at the end because we killed the service.
And we have injected so far half of the 2,000.
Okay.
So let's redo it.
Yes.
And I will work on the UI.
So we are going to use AngularJS for the UI now.
And what is nice here about the way we develop the stuff is we have the application running, we have the services running, and what I want to do, it's using the same API, the REST API, I want to create a new UI. So I don't need to do anything with my server anymore. I just need to create the client. So let's check out the view part, and we'll show you some of the code. So on the server side, it's the same service. In the web app, so we still use a REST API. But in the client part, what we have done is we just use the JavaScript layer from Angular that allow you to call API and get the data in a global variable that is a scope that you consume inside your UI. So in this example, we don't use one of the features of Angular that is resources, just to show you specifically the UI in the context of the controller. So if I want to get the list of the user, I will use the entry list, do the query, execute, get back the data as entries. How do I show that in my GSP? Sorry, mistake.
Mistake.
In my view, I will use the entry object, that is a list, and using specific tags from Angular, so ng repeat, I will repeat on all the entities, all the entries, and I will show you, using the standard kind of JavaScript dot notation, I will print the information, so the name. So since we use the same web app, and I should be able to only refresh my page and get my application using the new UI. So black menu was the standard Twitter Bootstrap GSP based. The white menu is based on Angular.
Can you search for Joe, for example?
So I can search for Joe.
Can we Joe Smith, perhaps?
Joe Smith should work also.
Can we modify it? Can we modify Joe Smith?
Yes, if we want to modify. Good UI. As you can see, I am not a very good web designer, and I think it's a Zoom issue. Still, I am not a good web designer. So we can modify the data. In this case, I'm sending back and forth the JSON document.
Can we look at this person into the CouchBase database
Yeah,
itself?
so in this case, I'm using the person number 0. That is, if I go to the bucket document, this is this person.
This one. So you have modified the number of cars.
Cars 12. So and JSON is using type. So we use integer, we use strings, we can use sub-element like address. Remember that what David said is we use multiple objects, person, address, meta ID, that were multiple tables. In this case, I have one single document that manages all my data. So easy to distribute on a cluster.
So can we search for more, for example? So we have searched for Joe Smith. Can we search for Smith Joe?
So Smith, no,
Smith.
Because my index has been built only on first name, last name.
Okay. And what about Germany?
I don't have, same as before in your SQL database, since I have not created not the query in this case, but the index. I cannot search for that, but maybe you can help us.
I think I can. Okay. So basically, remember that we want to push our document from CouchBase to Elasticsearch. So we have here an Elasticsearch installation. We have only added the CouchBase transport plugin, which helps to replicate CouchBase data into Elasticsearch. So the first thing I have to do is to launch Elasticsearch. You just need to provide a JVM, that's it. So Elasticsearch is loading, is listening on multiple ports. The REST port is this one. And I'm going to open an administration console, which is built by the community. And in this console, I'm going to create a new index.
So what is an index?
So an index is the place where we are going to hold your document and store your documents and your index, in fact. So this will be a person. The name of the index will be person. And we are going to set the number of shards. Each index is split into shards. And behind the scene, a shard is a Lucene index. And this is how we scale out the cluster. We are asking here as well for a number of replicas, which is the number of replicas per shard, which means here in my cluster I want my index split into 5 shards, and I want 1 replica for each shard. So I'm done.
You are done?
It's your turn.
So the next step is how do I integrate my documents that are stored inside CouchBase into Elasticsearch to be able to be indexed in a full text way, but also in giving us, I hope, the Smith Joe that we were talking about before. So as David said, is as part of the installation of the Elasticsearch we installed what we call the CouchBase transport layer. So it's the transport API from Elasticsearch that give access to the external system. And as you can see from here, so this allow me to connect CouchBase to Elasticsearch. And what we use for that, we use one of the features of CouchBase, that's XDCR, cross data center replication. It's something you use when you have multiple clusters, for example, in the US or in Europe, and you want to keep in sync your two clusters to have the data close to your user or to use that as a live backup for your system. So what I have to do in this case, I'm just saying, okay, where do you want to push the data? In this case, I will use a single direction. So from CouchBase to Elasticsearch, and I will say Elasticsearch will be the name of my cluster, target cluster, and
we are running everything on localhost.
By default, I'm using this port. And what I have to do here now is it's configured to go to this specific cluster in Elasticsearch, but I want to say which data do I want to push from CouchBase to Elasticsearch. So from this cluster to Elasticsearch, in default, because this is a bucket, so this is a schema or the database that I am using to all my data, in the index person. And you see we have no documents here. So let's go to person, yes. And I start the replication, and it is done. So it's starting up, and what can you do from that?
Perhaps you can see if it's working or not.
Yeah, so it's starting up, kind of waking, okay, it's replicating.
So I'm going to refresh. Okay, you can see the number of documents which is increasing now. So basically, CouchBase is sending all its documents to Elasticsearch. So now remember that we have a REST API with Elasticsearch, and the next step is to move our search directly to Elasticsearch. So this search directly to Elasticsearch. So for that, I'm going to change the branch.
So it's the same. We have built some new branch. Here we are changing the part of the UI to integrate this call to Elasticsearch.
The cool thing is that I don't have to restart my server here. Just have to build it. So I'm going to show you the end of the job. So it's in the controller part. Let me show you. Where is that? Yeah. Oops. Where is that zoom?
As I say, we have not.
Can you Can you unzoom? Oh, that's it.
We have not built the best architecture. Many port on hostname hard-coded, but it's just for the
demo
purpose of learning and sharing that with you.
So before we had
zoom a little.
I'm sorry. Yeah. That search implemented. So we were connecting to the old REST API, and now we are connecting directly to Elasticsearch here. So basically, it's somehow the same endpoint with underscore search and the query. Then we have the first 10 results by default, and this is what we display in our views.
That's it?
Let's look at it. So we change some few things. For example, we have now the total number of hits and the time. So we can search for Joe.
Are you sure?
As it's really fast, we can have the search as you type feature. So I can search for Joe Smith.
And we have talked about Smith, Joe, and can you do it?
Okay, I hope. Smith, Joe, that's it.
And we talked about earlier, be able to search in other field. And I see city or country. Can I work for, Germany?
Germany, so we have that number of documents that correspond to this.
Can you quickly give me some information about how it works? Because I didn't say that I am indexing or I want to search on Germany or country, sorry.
Yeah, by default, Elasticsearch is indexing all the JSON documents. So you have a fine control of that. If you don't want to index everything, you can control that. But by default, we index everything in Elasticsearch. So as it's indexed, you can search on it. And
do you think as it's indexed, we can continue to inject data in the database?
Yes, we can. So let's inject 1/500,000 documents.
So what will happen here?
So it's basically continue to inject, and if I update my search, I can still search on Joe, everything still in real time. I don't know if you can see the number of Joe who is changing.
So it's going to CouchBase, saved in your database, and pushed inside Elasticsearch for indexing. Like that we can always query.
Yeah, so maybe we can try to search. I don't remember if it was, for example, I want all Joe, but I don't want Smith, for example.
So you can do more queries. For example, if I want to search for people in Joe that are not in London.
So the first one, for example, is in London.
Yeah.
So if I said I don't want London, okay, I don't have London. I have the Joe, the Smith, and not London.
If I remember correctly, based on your Java object we had in our Java application, you had a gender.
Oh, yes.
Can I do something with that?
Sure. So we want to search for male, for example, and we hope that this Joe Smith is a male. Oh, it doesn't work here. I think it's a UI issue.
As you can see, we are more server-side than client-side.
So it still continues to inject, in fact.
So it's good to be able to get all this information from my UI, but more and more users want to create dashboard based on the data. And what I have to do, I have to create my Java application, all the REST APIs, the new HTML to do that, or can you help me?
I think I have an answer.
I hope that.
And the answer is Kibana. Kibana is a project that we built at Elasticsearch. It was built on top of Logstash project historically. But now Kibana is a generic UI you can use on top of your data, whatever your data are, wherever they come from. And you just have to make sense of your data. This is really what we want you to do. So I'm sorry. Kibana is built with AngularJS as well. So everything is running in the browser here. So I'm starting, magnifying that. That's okay. It's okay? Okay. So I'm starting with a blank dashboard here. So I'm connected to Elasticsearch. The first thing I have to do is to set my dashboard, and I'm going to say my index is person. So I want to make sense of the person index. Okay. I can run a first query. Joe. Okay.
I don't see, it's not very interesting.
Oh yeah, you're right. Maybe
I can do the same.
Maybe we can show you the number of hits. So let's add a new row. Think about analytics. Twitter bootstrap rows, for example. So I add a row. And now I have a row, I can add panels into rows. So the first panel I want to add is the hits. And I want to display the total number of hits bigger.
So here you are just building the UI, so adding some component based on the query you will be running.
Yeah.
And you do that live.
Yes. So for example, now the number of Joe is still growing. Okay. Let's add, I want to have also the number of John. So I have the number of Joe and the number of John. But what is the distribution of Joe and John? Let's modify this panel. And instead of displaying the total, I want to display a bar. So here is the number of the green and the yellow. So let's add the legend here. This is Joe. And this is John. Okay, you can see the number of Joe and the number of John. I don't know if it still continues injecting. No, injection is over. Remember that we have a date of birth. So we can build what we call facets. And we can build a date histogram facet here. That means that we want to break by date of birth our results and display the numbers. So I'm doing this. Oops. Okay, I have only one issue here. No, not here. I forget to say the field name is not timestamp, it's date of birth.
So I see that you can get the name directly from the document. It's you have a auto-completion kind of stuff, a suggestion of the field.
Sure, because we are in the NoSQL world and we are in the schemaless world. So basically, you can send every JSON document you want, and Elasticsearch will adapt what we call the mapping, and then Kibana will make use of that mapping to display the name of the field we have in the documents. So here is the distribution of Joe and John broken by year. Let's have a look at the gender. I can build a terms facet. We call that the gender. The field name is gender, and I want it as a pie. Okay. Ooh, that's strange. We have Joe and John who are females.
So I'm not really interested by the female named Joe. I'm worried.
Yeah. So let's have a look at it, and I want to display our results. So results, I'm going to build a new row here and add a new panel. The name of the new panel is the table panel, which means that we are going to display results.
So not only you can do aggregates on some graph, but you can also directly extract the data.
Yeah, sure.
And how it looks, JSON documents?
Oh yes, it's JSON documents. But as you can see here on the left, we have the mapping, what I just told about, you about just before. So we can now select the field we want. So let's say we want the name, we want the date of birth, we want the gender. The country, easy interest in fashion and food and whatever. Okay, these are my fields. But remember that I have a concern with the female. I don't have a concern with females. Okay, right? This is just an example. So now I want to click on that chart, and I want to filter my result. So here, I'm sorry.
You can use the graph
here we have
as a filter for you. Okay, you can so you can really drill down based on anything in the dashboard.
Exactly. So here I have all the female name Joe and John, and John is the last name. So that's okay.
And one thing that bothering me is, do I have to create this dashboard every time by hand? Click, click, click every time, or can you save it or reuse it?
Of course, you can save it as a file, or you can save it in Elasticsearch itself. So you can reload it when you want. So I have built before a dashboard here. So for example, this is the number of Joe and John broken by year, with the country, with the cities here, and the results. And let's say that you have an interest of females.
For example, next week I'm going to Germany. So if I want to find somebody to have a nice dinner, for example, in Bonn or in globally in Germany or in Berlin or Bonn, I don't know if you can do something.
So let's filter in Germany. Yes, you want Bonn?
Yeah.
Okay, Bonn. And perhaps you want someone who has the same age.
Yeah.
So here? No, 70s. Okay, that's it. Okay, so in the 70s, now I have all my filters here. You can see the filters. And we have the result. Our result and dataset is here. What we can see is on each document, we can click on it, and we can see all the fields in it. We can view that as a JSON, as a raw document, whatever. We can filter. If I want to show, I don't know, whatever. This zip code, for example, I can apply a new filter on top of that.
So what is really interesting here is you see that even when we talk about NoSQL as schemaless, at the end you have a schema somewhere in your application, but this schema is part of your document you save inside your database, but also that you can index and search, because you have many attributes and sub-elements inside your JSON document that we use in the database, we use in the UI, we use in this dashboard to make sense of your data if you want to search. So quite interesting to see that you have the flexibility of working without schema. I save data without creating a schema first, but I have the power of query them or organize them by specific attributes.
Yeah, for example, here I modify a little the query. I'm interested in a person who likes cars more than 1,000 times, so I can drill down on every value. So here we have nice data, but maybe our marketing team has a crazy idea and want to modify some things, and maybe they want to add the Twitter account or whatever. Can you do something in your interface or in CouchBase? Do you have to call a DBA? I don't know, and stop the world?
I hope not. How many DBAs in the room? Because one of the things that NoSQL globally trying to do, in addition to have scalability and powerful research queries capabilities, it's to give you a way to be more agile, to more efficient when you want to add new feature. Especially, you have to keep in mind that we may have a lot of documents, a billion of documents. And the marketing team can come anytime saying, now I want not only to use this person's objects, but I want to add some information about their social network, so Twitter and Facebook account. And you want to do that for yesterday, as usual from our user. So what we have done with the way we have developed is using the REST API to exchange document. And maybe I can just test to change my UI to add this field and see how it goes to the database and how it goes to my dashboard. So no need to change my service layer because I'm working on an internal application, so no need to validate many things. And I will change my form. So my form, as we said, is AngularJS application, and I have all the information on what I will do here. In addition to the country, I will add information about social network. Let's start with Twitter, and I will call it Twitter. And because we use JavaScript notation, we can use embedded object. And instead of an address, I will use an object that is named social that will contain the different social network attributes. So Twitter in this case, and I will create the same with Facebook. Facebook, I'm lazy, so I replace Facebook here. So just changing the form. So what I will do for that, I will get back to my application, and I will stay with Joe Smith. And I will use the first one just to be sure that we don't have any issue. I will, to find it inside the database, I will use my document database to look into it. So inside CouchBase, I can find for it. So you see some information about the user, nothing about social. I will I just save my form, refresh it, and I see my nothing magic here. You're kind of, this one is easy. So just I have the form, and I will add my Twitter and our Twitter account in both stuff. Saving the data. So saving the data back in the database as a document. If I go here now, let's see if something has changed. We have modified the document that is saved inside the database. So as you can see, who is driving the schema now? It's your application. The challenge now is, can I search this data?
Of course, I hope so. Oops, sorry. So we have the Douane, for example. Can we find it? Oh, no luck. Do I have filters? Yes. So I remove all my filters.
Yeah, remove.
Okay. So I have now one document with that field. And as you can see here in the list of fields, that I can now display the...
Automatically, you recognize a social object containing
that one.
Facebook ID and Twitter ID.
So here we go. We have the document. So we are really in the pure schemaless world. And this is really powerful.
So really one of the stuff we really like about NoSQL for developer, it gives you more power. It gives you a way that you love again your data. You are in control of your data. You are in control in the way you're manipulating them. If you want to change a schema, even if here I have billions of documents, modifying this specific document doesn't impact in any way the existing database. That means you can do that on a running system. You can do that without impacting the production. And this is key because when you develop large application, you want to be sure that you stay up and running, not only your middleware, but also your database.
So let's scale. We have some minutes. remaining, so let's scale. I'm going to start a new Elasticsearch instance on the same physical instance.
So you are creating a new node?
Yeah, I'm creating a new node. And let's look at it here. Oh, you zoom that. Okay. So I connect now. I hope it works. Oops. Yeah, but this one is not important.
It should be another port. So this exception is due to some of the configuration we have in the transport layer. And
yeah, I think, yep. That's strange because it started. Okay. This is the demo effect, I think. Okay.
We failed to scale.
We failed to scale.
So usually, obviously, you don't use one machine to do a cluster with multiple VMs. So let's see if it's working again. But
I'm trying again, but I'm wondering if we have something wrong in the because we have the Wi-Fi before. So maybe, don't know.
Yeah. So, but yeah. What are you trying to achieve? Is to add new nodes to your cluster.
Yeah, basically.
But can you give me an example of the type of configuration you see in your customer or people using Enterprise Edition or Community Edition of Elasticsearch? What is it's a one-node cluster, what you see?
No, the biggest cluster I have seen with one of our customers was a 150 nodes cluster.
Which type of data?
I'm sorry?
Which type of data do you store?
That was hotels, rooms,
okay,
and reservation. And another big cluster I have seen is the GitHub cluster with a billion of code lines indexed. And if you use it every day, I think you use it every day, you know that it's fast and pretty fast. So it scales very well. And what about you, about CouchBase? Do you have big clusters in production?
So one important part about big is for what is used and how it's used. Yes, we have cluster of 80 nodes. For example, who knows the game Draw Something? So it's a game that, like a Pictionary online. And Draw Something has started with a 6-node cluster. And 6 weeks after, because they moved from 0 user to 50 million users, 16 million of users daily, to an 80-node cluster with 2 billion of images. And what they have done is they grow this cluster on Amazon. On how they have done it, maybe I can quickly show if you.
I'm sorry.
If I can touch a mouse.
Sorry.
So the way you grow the cluster, it's either you use command line, or you can use, for example, here you will say, I want to add as part of my server, of part of my cluster, new cluster, the new node to my cluster, and here I am using one of the VMs that I have. And I can add more nodes, as much node as I want, and I will just, when I am ready to rebalance the data, because most of the time you don't want to add one node on one node. You know that in 1 week you're doing some marketing events, you want to move from 5 nodes to 10 nodes, you add all the nodes, you click rebalance, and it will move the data, redistribute the data on the different nodes of your cluster. So in both cases, when I say both cases, in Elasticsearch and in CouchBase, not only you can grow more data and more users because you distribute, but remember that you distribute the read and you distribute the write on many, many nodes inside your cluster. So you can really scale out your application without having any issue about performances and processing consumptions, because if it's starting to slow down, too much data, too much user, just add new nodes and redistribute the data.
So I think that we have moved our application from SQL to NoSQL. So it's time to conclude, I think, yeah. In less than 1 hour. Almost with the cluster thing. If you come to my session tomorrow at noon, maybe I will be able to show you that.
They will complain about my laptop, saying it's my laptop, that is the issue. Just remember that everything that we are showing, we have showed to you today is available on GitHub. If you want to quickly test, quickly learn, do not hesitate to check this card, even contribute if you want to have a better AngularJS application, for example.
Yeah. We have 7 minutes for questions, I think. So do you have any question? or outside if you want. Yeah.
Yeah, if you just add records that have kind of a schema change implied, then with the time you have like 10 billion records, and each has a different pattern, and you have to deal with the complexity that the software has to deal with different generations of data, or do you migrate?
So the question is, when your application is living, you may have multiple schema because you start with one version of the document, you add new attributes, you remove attributes, you add another set of attributes. How do you deal with that? So you have two things. It really depends of your application on what is the logic you want to apply to that. What we see in a lot of cases is people are putting inside the document a version of the document, but not a version of the document itself, but a version of application that is using this specific document. So like that, when they get this document out of the database, they know if they want to migrate or not the schema to a specific version. You don't have an alter table that will modify all the documents. You can write it if you want, but what we see in real life is really people are doing that in a lazy way. When they are accessing some documents, they will modify the schema. And they deal with the complexity of having multiple schema. It's not necessarily a big deal. What David has just showed us, is suppose you know that you have an old version of the document that has a specific field. Just query it and modify it if you want to. But most of the time, you may not need to. And I will say, you do that today with your relational database. How many of you have these 5 or 10 fields that are just generic and you put any crap in it? Many, many crap in this. You have to deal with the same of getting the data to know what it is. In this case, it's a lot easier because you choose if you want to store the data or not, if you want to migrate or not, this specific value. Anything to add?
Yes, from Elasticsearch point of view, if you need to change some rules, for example, indexing rules, let's say that you index a document which is in English, but now you have a field, the same field is going to hold the French version, for example, you will probably have to re-index your document into Elasticsearch because the rules have changed. So this is basically what you have to do.
Other questions?
Yes. I can see you. Yes, you.
I wanted to know on the side of Elasticsearch, what would be the ratio of the size of the index compared to the data?
Yeah. The question is what will be the ratio on between the size of the data and the index then? The answer is it depends. So I don't have an immediate answer for that. By default, we store the source document you sent. We indexed each field individually. And then we have somehow a big field where we put all the JSON field into it and we index it. So we have 3 times the document by default. But you can change that when you want. And on top of that, Lucene is using now compression. So it's really hard to say how many times you will have and how much it will cost you in terms of disk space. I assume that if you have not strong requirements, for example, if you are not using what we call n-grams, you won't generate too much tokens in your index, so it won't cost you so much size. But you have to test it. The only answer is test it. Just test with your data, send it, and you can measure that.
So that would be several times the size of your data?
It could be less. It could be less.
It's like your index in your relational database. If you index all the fields in your relational database, you will kind of double the size of your database or even more. If you choose some specific field, it will reduce the size. And after that, you have all the Lucene optimization also at the top of that.
We have time for
another question.
Last question.
Yes. What licenses are involved?
So the question is, what license are involved? I will start with CouchBase and I'll let you answer. So CouchBase is an open source on Apache v2 license. So you have a community edition you can use as much as you want in any environment. And we have an enterprise edition that is the same, more or less the same source code, but it's coming first before the community edition with a specific user license that allow you to use it as much as you want in development and test. But if you want to move to production to more than 2 nodes, so starting at 3, you need to you need to pay the support. And obviously, most of the biggest part of the installation is on community edition. And depending on your requirements, depending on the maturity of your project, people are moving to enterprise.
Yeah, for Elasticsearch, it's Apache 2 license as well, for Kibana as well, and for Logstash as well. So use it freely. Just test it. Yeah, sure.
So Elasticsearch and CouchBase source code are available on GitHub, in addition to our nice application.
So I think we are done. Thank you very, very much for your attention.
Thank you.